Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Raphael Knut, your host. I'm a contributing editor at Data Science Central. I'd like to start our event off today by thanking Tableau for sponsoring today's event. Tableau is a longtime supporter of the Data Science Central community, and we are honored to have them sponsoring our event today. Today's webinar is entitled, How Does Tableau Help You Ask the Right Questions?, to be presented by Tableau. Before we begin, I'd like to briefly review the format of today's webinar. Today's event will be 1 hour long. We have one presenter who I'll introduce in just a minute. There will be a 10 to 15-minute Q&A following the presentation. And this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. I'd also like to encourage our attendees to provide questions throughout the presentation. We will be reviewing and presenting them on your behalf during the Q&A portion of today's event. I'm very pleased to introduce today's speaker, Ross Bunker with Tableau. Ross Bunker loves writing software that solves real problems for customers. At Tableau, this work fundamentally centers around helping users ask more questions of their data and find meaningful answers. In his 14 years at Tableau, Ross has worked on many areas including calculations, data blending, query processing, and visualization processing. Thanks for being with us today, Ross. We're looking forward to your presentation. At Tableau, our goal is to make data analysis a delightful experience. People tell us that when they are deeply engaged in data science, they stop thinking about the mechanics of the software and just have fun asking questions of the data. But if you have to start thinking about how to use the tool to solve the problem, the state of flow is broken. One common cause of this is the need to work with data that has multiple concepts within it. These concepts may have multiple levels of detail, and many questions can require accessing multiple concepts at once. In today's Data Science Central webinar, Principal Engineer Ross Bunker will delve into the important concept of level of detail, LOD, and how it affects both your data and the questions you ask. He will also discuss various features of Tableau and how they can be utilized to visualize answers to complex questions that involve LOD. Ross, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Okay, thanks, Raphael. Pleased to be here, everybody. Always love to talk to people enthusiastic about data science and getting answers from data. Before we start, I wanted to quickly ask everyone to fill out this information about how often you use Tableau, just to help me be able to get a sense of how much Tableau to talk about versus how much to focus it more on more generic usage of data. So we'll just take a couple of seconds to let people answer, and then I'll have a good sense of where to go. Okay, thanks everybody. So today I want to talk to you about how Tableau helps you ask the right questions. So we're going to talk first about how questions impact data science, and then talk a little bit about level of detail. So this concept, and I'll abbreviate it LOD a lot. It's kind of a term of art, but we'll discuss exactly what level of detail is and try to understand it better, and then go through a history of how LOD has sort of evolved in Tableau and affects how you use Tableau, and more generally how it affects the types of questions you ask and the answers you see. And then I will talk at the end a little bit about the future of LOD in Tableau, and in general this will kind of help people understand how we can better model data to let us access these different levels of detail. So, in data science, I found this wonderful visualization on Dr. Roger Peng's blog, Tukey Design Thinking and Better Questions post that he had on simplystatistics.org. And, a lot of times in data science, as he shows you here, we think we're on this right side, right, where we think of data science as the thing that gives us evidence to back the answers that we have. And we always think we start with this great question, and we want to sort of, use data science to help us get really strong evidence for our answer. But as he points out here, really we often start, and our question is not actually necessarily as refined as we might think. And the importance of moving to the right here along the quality of question axis is really important part of data science that we often don't give enough focus to. And so while machine learning and statistics and visualizations and all these sorts of things move us vertically, it's up to the people and the humans to really refine the quality of the question, because the computer itself is not always very good at really helping us or doing the work for us to improve our question quality. And quality of question is really important. Dr. W. Edwards Deming is a famous civil engineer and really the father sort of modern business process management. And he has this wonderful quote that if you do not know how to ask the right question, you will discover nothing, right? So the idea being that the question quality is as important, if not more important, than anything else, because the right question is really important in figuring out how to use the data you have and apply it to answer the questions and solve the problems that you're trying to solve. So I took this quote and I adapted a little bit for Tableau. And so, if Tableau doesn't let you ask the right question, then you discover nothing. And more generally, if your tools aren't letting you ask the right question, or if you aren't using your tools to ask the right question, regardless of what they are, then you will discover nothing. So how does this impact how we ask our questions with the data that we have? So I have this here, a visualization that I produced with Tableau, and I want to kind of, it's showing me a visualization, but I want to back the other direction and try to figure out what is the question that this visualization is answering. And so, you can see here that I have product on this axis, on the horizontal axis, and I have sort of the sum of sales on the vertical axis, and it's broken down also by color, so I can see the product type categories for each of these products. So clearly product is involved, sum of sales is involved, and really the question is relatively simple. What are the total sales of each product? And then help me see by product type too. That's where the color comes in. So this is a fairly straightforward example of how my answer here is being manifest, how the question is being evoked from the user interface here in Tableau, and it's showing me what the question is that I'm answering. But it isn't always so easy. And in particular, here's another example. What is the question here? Well, I have call center region, I have count of employees, I have employee salaries, and if I divide the number of employees, if I divide the employee salary by the number of employees, you'd think that I would get the number of the salary of each employee in each call center region, or the average salary of the employees in a given call center region. But if we look at this visualization closely, it's saying that I'm paying my average employee $3 million plus, which seems a little excessive. I mean, that would be great, but I don't know that that's actually what's happening here. So even though that looks like the question I'm asking, it seems like it might not be correct. So let's dive in a little bit under the covers and see what's going on. And this is what we call the replication problem at Tableau, and it has to do with what the level of detail of the data is. So if we look more deeply at one employee, we can see that, yes, indeed, it looks like we're paying them, this employee, $1.7 million, which I may know is incorrect. And so we, using Tableau, it's nice we can drill down into the data a little bit, so we can look at the underlying data. And you can see here what's going on is that for this employee, their employee salary is listed multiple times. In fact, it's listed many times, once for each product that they've sold, right? So the issue here is that the LOD of the data here is at each product that I've sold, and their employee salary has been replicated for that because the employee sold that particular product, and the employee salary is associated with the employee, not with the product. So since the employee appears multiple times, their salary appears multiple times. And this is an example where even though the question seems apparent from the fields that I've used on the visualization, the data that I'm using to do this has produced a result which is not really the answer to the question. The question I actually asked was something along the lines of, for every product, what is the total employee salary weighted by the number of products that that employee sold, right? Which is not at all what I wanted to ask. So that's kind of an example of how the level of detail of the data can impact the questions that you're asking. But let's take one step back and talk about what level of detail is, so we get a concrete definition. This is a visualization that Alan Eldridge, one of our esteemed sales consultants here at Tableau, developed to help explain level of detail to Tableau customers. And I just want to go over it a little bit to explain the visualization, because I'll be using it throughout the rest of the talk to cover a number of scenarios that we go through. So on the left, you see we have this sort of aggregation arrow, and there's less aggregation as we go down and more aggregation as we go up. And on the right, we have sort of the reverse of aggregation, which we call granularity, right? So more granular, more fine detail as we go down, and less granularity, more coarse information as we go up. And then what we have is sort of these arrows and numbers that represent measures and dimensions. And what you see sort of is that at the top we have a totally aggregated number, right? So this is like one number, like sum of sales for everything. And then what these arrows represent is in Tableau, you drag out dimensions and it starts to break down your measures by those dimensions. So I might drag out employees or products or states or countries, and I get more and more numbers, I get more and more granular data as I drag out more dimensions. I get less aggregation, I get more of these quantities as we go down. And so this is, and at the very bottom, we get to the totally disaggregated data. So this is the granularity of my data source. It's one row for in my data, one number for every row in my data, and that's the granularity of your data source. You can't go any lower than that, right? Once I get to every row in my data, I can't get any more of fine detail. So this visualization sort of represents a way to look at the level of detail of a number, right? One of these measures, and we'll use this later on in the presentation. So that's one way to talk about level of detail. Other ways to talk about level of detail, I mean, if you're familiar with SQL and you look at how this turns into queries, right? So these arrows represent group by columns in a SQL statement. You've got the numbers are your measures, like sum of sales or sum of profit. And so, one way to talk about level of detail is sort of the number of group by columns you have in your SQL query. If you're using cubes and you're using MDX, then it's how many dimensions are involved in the query and all that sort of thing. So there's a number of different ways to talk about LOD. But I want to really talk about it in really concrete terms because I think that's more how people think and less how computers think. So I want to start with an example of data in a very concrete form. So this is a purchase order that I might have, and this might be the source for some data, right? And there are many things in a purchase order. If we talk about the different elements of this purchase order, there's a salesperson, there's the producer, the person who's actually producing the item that we're purchasing. There's the purchaser, the person who's buying this is the customer who's buying the item. There are the products that the person is buying. So each one is entered here in a row of this form. There's the company that is the sales company that's facilitating the purchase. But actually, there's multiple companies. There's the seller company. There's the purchaser company. and those all appear. There's also multiple states, right? There's the salesperson's state, the purchaser's state, and the producer state, all location information for different entities that we're talking about here. Finally, time appears, not only on the order date, but it's not pictured here, but there's also a ship date. So some of these things, entities, appear in multiple ways associated with different elements of this. And now if we think about this data, we can also think about the kinds of questions we can ask given this data, right? So there are a lot of simple questions I might ask. I might ask about total sales by date, in which case I'm going to use these two elements to help me answer that question. I might ask about the number of products, the number of units of product X that were sold, in which case I would use these two pieces of information in order to answer that question. I might also ask a question like, who was the highest volume producer in each state, right? So I would look at the producer states, and I would look at the number of things produced by each of those people. I might ask about what zip codes had the most purchases, in which case I would look at the zip code of the purchasers and the total sales for each of those. So all of these questions use different characteristics, different elements of the purchase order to give me an answer. And so one way of defining LOD then is to say that for this given set of characteristics, for this set of zip codes, or this state, or this product name, or this salesperson, what is the measurement? How many sales did I have? How many purchases did I have? What is the quantity of things sold? What was the total commission paid? All of those sorts of things. So the LOD then is really the set of characteristics that you use to define the things you're measuring, right? So these are, characteristics and things, great generic words, right? But the point is that you have some measurement, and then you have these characteristics associated with the measurement. And the characteristics are the things that define how that measurement is given meaning. And it's those characteristics that define the level of detail. And if we think again about columns and tables and all that sort of thing, that's great. But I really want to pull it back to the real world. Like, these are real world things. A zip code is a place. A salesperson is a person. And those are real elements of the world that we're using in order to define these measurements. And again, getting back to why this matters, the LOD is what you're using to define your question. And how that LOD manifests in your question is very important in figuring out your answer, and in figuring out and making sure that your data is answering that question for you, right? In the example that we gave at the beginning with the mismatch where we had the employee salaries, the problem was that I was using a level of detail of data at the product level of detail. I had one row per product, and I was trying to ask a question that related not to products but to employees. And my employees were repeated for every row. And so the level of detail of my data did not match the question that I was asking. I needed to do something different in order to answer that particular question. And getting back to the where we started with this, we think a lot in data science in terms of finding answers, but it's really questions that drive this process. And so we need to continually be aware of the question we're asking and how that question is impacting the answers we're seeing in our visualizations and our tools and our queries and whatever else we're using. Okay, so that's sort of framing level of detail, why it's important, why it matters, and how it affects the questions we ask. So now I want to step into Tableau a little bit and talk about the history of level of detail within Tableau. And some of you are maybe not Tableau users or haven't used Tableau a lot. Really, all of this applies in any data science scenario, and just has to do with how you formulate the queries and the extraction of information that you're using from the data you have. And what I want to talk about is just how level of detail sort of evolved in Tableau in terms of the features we added, which are things you can use in lots of different tools. So the very first level of detail, which is apparent in Tableau, is what we call the LOD of the data source. Tableau's data model exposes a single flat table. So when you create a data source in Tableau, logically what you're connecting to is a flat table of data. And if you view underlying data in Tableau, you'll basically see what we call the row LOD, right? So the level of detail of a single row of data per per piece of information. And so you can see here an example of what that looks like, and it looks like a table of data that you would find anywhere. And this is a really important LOD because it's where everything sort of starts in the system. And it's, as we talked about with the employee salary example, it's very important to understand what that row LOD is in order for you to understand the answers that you're seeing. So the next LOD that's really important is what we call the viz level of detail, the viz LOD. And this is really the LOD that is the most prominent and is sort of the central to the visualizations that we display in Tableau. What you see is that you start off in Tableau, you drag out a measure, and it's totally aggregated, right? If you're thinking in terms of SQL, there's no group by columns at all. It's just sum of sales, right? So all the sales that we have. And as you add more dimensions to your visualization, you're essentially adding those characteristics that we talked about, those things that you are breaking your number down by, and those are the dimensions in the visualization. So for example here, we go back to this first visualization we all looked at. What are the total sales of each product, and help me see by product type too, right? So I have sum of sales out there, which is my measure in green. And then I have these two dimensions, product and product type, which I'm using to break down this question and break down that sum of sales number that I pulled out there. And since my level of detail of my data is product, sales level of detail, this answer is perfectly meaningful. So the viz LOD is really important and really useful, but it turns out that some questions are more complicated than that. So another level of detail that you can access in Tableau is the summary level of detail. And there are a bunch of features that let you summarize data. So totals, reference lines, table calculations. If you're familiar with Tableau, you'll understand those concepts. If not, these are sort of standard things. Totals and table calculations are just windowed calculations like running sums and difference from previous and some of those sorts of things. But the key here is that I haven't lost my viz LOD, right? My viz LOD is still there, but in addition, I now have this summary LOD, which, if you look at this graph, or this image is sort of, quote unquote, higher, more summarized, more aggregated, as you see on the left, less granular, if you prefer thinking about it in those terms on the right. It has one or more dimensions have been removed to compute the number, right? So this lets me ask some questions that are maybe a little more complicated because I now have two levels of detail. I have numbers from two different levels of detail involved. So what can I do with that in Tableau? So here we have a visualization where I have the same information as before, the product, the sum of sales, and the product type. But I've now got this reference line, which is showing me the average sales of all these different products. And I can now have a question like, how do my individual product sales compare to the average sales for all products? And so I can easily see on this visualization the relative length of the bar compared to this reference line. And so I'm seeing the same information I saw with my first question, but now I have this added extra information in it that lets me answer a more complicated question. I'm accessing another level of detail within the same question. So that's one of the first ways that we introduce a second level of detail into Tableau questions. But there's many others. So you'll notice here as well that I I haven't asked the question, what is the average sales, right? So if I look at average sales, my reference line will show me, the average sales of every product is 196.4. But in actuality, if I was to look at what we've done here with this reference line is not looked at the average sales. We've looked at the average of the sum of sales, right? So we first compute that sum of sales for everything. Then we compute the average. That's very different than computing the average from the very beginning. Those are very different numbers, right? This number is $196.4. So that's the average of the averages. And here we have the average of the sums. And so this ability to sort of do one level of aggregation and then do another level of aggregation after that is a really important capability. So the next level of detail I want to talk about is the filter level of detail. So a lot of times when you are trying to refine your questions, you want to look at a subset of your data, and you do that by filtering. And when you filter, you access perhaps a different level of detail. So what happens in Tableau and what you can do with SQL or any other language is you can perform a calculation at one level of detail to help you refine a particular dimension, for example, the set of customers you're interested in, and then apply that filter, and then take the resulting remaining rows and aggregate them to your viz level of detail. And that actually accesses multiple levels of detail to do that. So, for example, how do sales of products fluctuate over time for products with lifetime sales of more than 40,000, right? So what happens in this is that we take the number of we take all the products and we compute their total sales over all time. So and we say only keep the products who sold more than $40,000 over all time. And then we take those resulting set of products and we do our normal sort of viz LOD of summing the sales, in this case to the month level of detail, and then we color them we break them down by product on color. So you can see that all of the sum of sales in this visualization are under $40,000, right? So we didn't just throw out numbers, any number that wasn't 40,000, we were throwing it out. That's not what's happening here. We've first taken all the products and we've looked at each product individually and summed it over all time and seen which ones are more than $40,000, and then we kept those, and then we applied this aggregation and broke it down by month. And that results in numbers that are smaller than 40,000 because the 40,000 filter was over all time, and now we're looking at things broken down by month. So again, you can see that we're looking at two different numbers here. The filter is looking at a number which is not broken down by time, and this visualization is looking at one that is broken down by time. So again, our filter is working at one level of detail while our visualization is working at another. So the next thing I want to talk about is what we call the extract LOD. So extract LOD in Tableau is a way that lets you redefine the source LOD of your data. So remember, we talked about the row LOD as being that sort of lowest level baseline from which everything else is built. It's at the bottom right here. And what we can do with the extract LOD is we can actually move that up. All right, so in Tableau, an extract is where we take the data and we move it to a new data source. Oh, can everybody hear me? Okay, it sounds like we're okay. Anyway, the extract LOD is an extract in Tableau is where we take the data from its original data source and we move it into our fast database hyper. And what we can do as part of that process is we can pre-process the data and pre-aggregate it to create a new, quote-unquote, new row LOD. So how is that useful? What does that let you answer? What kind of questions does that let you answer that you couldn't answer otherwise? So here is an example of a question I might ask of my data. What is my average sales per month? What is the average monthly sales for each year and quarter? Now, if I just do this with row-level data where I have daily information, if I put average sales out here, I don't actually get the right answer. It might look like that's what I'm asking, but it's not. What I'm actually asking, because again, we have to think about where the row-level detail is, it's daily. So this isn't showing me average monthly sales. It's showing me average daily sales, right? And we can verify that if we look at the daily information, right? So if I go down to the day level and I look at my averages, they're here in the, 1,000 to 2,000 range with these spikes that are a little higher. And so if we kind of go back here, you can see, yeah, okay, 1,500 to 2,000, that's my average. So that's really showing me my average daily sales. If I look at my monthly sales, not averages, I'm just looking at, now I have it broken down by month, and I'm just looking at my total sales for each month. You can see that it's in this sort of 10,000 to 15,000 range, or 150, what's that, 1.5 million, 1 million to 1.5 million range. So if I'm looking at my averages for a quarter of monthly sales, I would expect numbers in that range. So what we can do is we can create an extract. And when we create an extract, there's this special checkbox, aggregation, aggregate data for viable dimensions, roll updates to the month. So what it's going to do is when it pulls that data out of its original data source, it's going to aggregate it to the month level. And it's going to do that using the default aggregation for things. So for sales, that default is to sum. What that's going to do is it's going to produce a new row level of detail, a temporary row level of detail. We call it the extract LOD, where all of my data is rolled up to the month level, and I have sums. And now, if I look at my average using that extract LOD as the input data, I'm now averaging those monthly numbers. And you can see that my average is indeed in that 1 million to 1.5 million range. So I've been able to ask a new question, my average monthly sales for each year and quarter, by extracting the data out to change that row level of detail to something that is compatible with the question that I have. So the next feature we added in Tableau that let me access levels of detail in interesting ways was geocoding. So in geocoding, I have information at some level of detail in my visualization, and one of the elements of that is a geographic information. So for example, it might be state. And what we're able to do is we're able to go out to our geographic database, and for every state, we're able to find the latitude and longitude of that state and bring it into the data. Now, what's important to understand is that my data might have multiple entries for each state. And even though it has multiple entries for each state, we're going to put the latitude and longitude in based solely on the state, right? Because the product I'm using doesn't matter. The latitude and longitude are associated only with the state field. And so what we're doing is we're taking a subset of the LOD, in this case the geographic subset, and we're using that to pull in extra information. So what is the sum of sales in each state, and how does it vary by product type? So what we've done in this visualization is we have states and product types, and each state is represented by a little pie chart, and it's been scientifically determined that the only useful thing for a pie chart is to put it on a map. That's a little joke we use it here at Tableau because pie charts are often vilified, but we've decided that this is actually one of the best uses. Anyway, the interesting thing here is that, again, state is just one element of this question, and we've used it to pull in this geographic information. And so this is a really handy thing to be able to do, to pull in this extra information on latitude and longitude, and enables you to view this answer in a very elegant way. But that concept of bringing in data at a different LOD led us to our next feature, which is what we call data blending. So the idea here is I have two data sources now. I have one data source, which is sort of my what we call a primary data source, and that's represented by our typical chart here. And I have a viz built for that with some numbers, and I have a viz LOD associated with it. But in addition, I have another data source that I want to aggregate data to, and I want to join it with my primary data source to help augment the information in my viz level of detail. And the way we do that is that we aggregate that second data source to a level of detail which is compatible with the dimensions in my visualization, and then we join on those shared dimensions, and then we're able to visualize the data. But those shared dimensions may not be all of the dimensions in the viz LOD. It may not be all three of these dimensions here. It may only be one of them. In which case, what we'll do is we'll have a number up here where the black arrow and the ends and the red arrow starts, and we'll basically replicate that value down to the viz LOD, so that for every row in the extra two dimensions that are in the visualization that aren't part of the join LOD, we'll just repeat that same number over and over again, and that can be very useful. So in this visualization, what we want to do is we want to look at our total sales in each market for each year, and we want to compare that to the quota for that region. Now, what's interesting about this is that if we have the we have our sales data in our usual spot, and then we have quota information. So this might be what our data looks like for the sales in each quarter for each market, and this is our quota information right here. Then what we want to be able to do is pull that data in, and even though the quarter isn't in here, right? What we've done is we've aggregated that quarter out. So we've taken all the 1998 numbers and we've added those together for each quarter in the central market to compute the final quota for that particular entry. And we can now plot that behind our sales and see how our sales compare, our actual sales compare to the quota. So initial version of data blending supported this idea of doing joins at subsets of the viz LOD, or again in this chart sort of above the red line, right? So the join LOD was always somewhere above the red line or at the red line, and that was how we built the visualization. But we saw increasingly that there were cases where customers wanted to be able to do joins below the red line at a different level of detail, and then bring that data up to the red line, to the viz LOD. And so basically doing joins on levels of detail that were lower, more detailed, more granular, less aggregated than the join LOD, than the viz LOD. And so how can we use that? So in this case, we have a question like, what is my profitability in each sales territory? Well, it turns out that sales territories aren't in our sales data, right? We have a different little data table that contains for each customer state what the territory is associated with it. And so what we can do is we can join our sales data on the state information, right, which is in both of them, and then we can actually continue to aggregate. So normally we would see by state our sales data, but because we've now added this new territory as part of the data, once we've joined our sum of sales at the state level, we can continue to aggregate that sum of sales up to the territory level. And so we can actually get a level of detail that didn't exist in our original data. We can augment our data with data blending to add this new territory dimension, and we can now aggregate to that and get answers to questions we couldn't ask with our original data. Okay, the final feature I want to talk about in Tableau is what we call LOD expressions. So LOD expressions take this notion of level of detail and really formalize it. And so with LOD expressions, normally what we've talked about is the viz LOD is sort of the central thing, right? We can do things at viz LOD, we can do things above viz LOD, we can even do things with data blending that are below viz LOD, but everything's sort of relative to viz LOD. And with LOD expressions, we introduce the ability to define an LOD independent of the viz LOD. And you can write an expression that lets you compute a value at a specific level of detail, and then we have logic that knows how to bring that together with the viz LOD in order to help you answer your question. So when you use a fixed LOD expression as a dimension, we actually join it back to the row level of detail, and you can then aggregate it all the way up to the viz LOD from there, and you can use it as a dimension, and that's very useful. If you use it as a measure, right, if we think back to the employee salary replication issue initially, you can see that there were cases where we wanted to relate information at one LOD to another one, and when we were replicating it too much. Well, when you use a fixed LOD as a measure, we try to bring it in at a level of detail where we minimize replication. So in order to prevent exactly that type of problem. So how can you use fixed LOD expressions to answer questions? In Tableau, you can say, does the month in which a customer makes an initial purchase affect the long-term spend? Well, the key here is that my original data doesn't have this quote-unquote month of initial purchase associated with each customer, right? I just have sales information. I know when customers made purchases. But I can write a fixed LOD expression of the form, fixed customer min purchase date. And what that means is for every customer, there is now a min purchase date which is associated with that customer. And I can now use that as a dimension to associate with each customer their the month in which they made an initial purchase, and I can compute their sum of sales for that cohort, essentially. And the beauty of it is that we will join it in at the right level of detail so that we won't replicate that information and we won't create incorrect measures. Okay, so we've gone through all these examples of how we've mixed different levels of detail to answer questions. And the big thing that stands out for me here is that asking a lot of questions requires multiple levels of detail. Now, this harks back to a quote from Jock McKinley, who's a longtime visualization expert, who's one of the early employees at Tableau and advisor for Chris Stolte, one of the founders, on his thesis, which was his PhD thesis, which was sort of how Tableau came to be. Early on in Tableau's history, they wrote a paper about how there is no single view. That is, in an analysis, you may want to use different visualizations in order to help you answer questions. And there's no single way of viewing data that is going to be correct for every situation. Similarly, I've adapted this again to say that there is no single LOD. There's no one level of detail that's going to answer all your questions for you. And many questions require multiple levels of detail to help you answer questions. And so I want to spend just a few minutes, just a minute or two, talking a little bit about things that are still difficult in Tableau and still challenging with respect to this. So we talked early on about the salary information, right, being replicated to the order LOD, and so you have to use an LOD calculation in order to unreplicate that information. From the purchase order data examples, what employees have no sales in some months, right? So our data tells us when they when sales occurred. And if there's a month there where there were no sales, it doesn't appear in our data. Now maybe month is unlikely, but you can certainly imagine days when no sales occurred. And do you want those days to appear in your visualization or not? And so that's one of those things that's still kind of challenging to do. Also, the ability to combine data that are at different LODs, like customers and stores, on a map, right? So normally, the way I describe blending, you'd be joining these things on some field that's in both of them. But if we're trying to join them on something like latitude and longitude, I mean, those customers and those stores never appear together. The only way you would see them together is if you plotted them separately on a map. And so that's something that's still very hard to do at times. And then finally, what are the average sales of my top 10 customers in each state compared to the rest of the customers in the state, right? So that idea of top 10 customers, well, I can compute that. I can compute the customers in the top 10, but then if I want to compute everybody else, I really have to do that in the database, and it gets very cumbersome since we can't do ranking in the database. It's not available in all databases. So future things we're thinking about in Tableau to help improve a lot of these things. Ranking in the database when it's supported, and if it's not supported in an underlying database, how do we provide you that functionality anyway? Another one is an ability to combine data sources with different LODs into the same visualization without requiring this data blending, the joining, right? So the ability to sort of overlay two different visualizations on one another. So on a map is a great example of being able to plot those stores and the customers together. We call this a layers project that we're working on. And then finally, the richer data modeling, so that a lot of data sources support multiple levels of detail, like that employee salary and order information, so that you don't have to sort of do data blending and all these different tricks to bring that data together. If we had a data source that understood the level of detail of all of the information in it, then you could just connect to it and do your questions without having to change data sources and blend them and all that sort of thing. So that's just a few of the things we're working on with LOD and with all of these questions. I hope that's been useful, and I think we're ready for questions.
Ross, thanks for that excellent presentation. We'll get started with today's Q&A session. I want to thank the audience for their participation. We have a great many questions that have come in during the presentation, and we'll do our best to get through all of them in the time remaining. During this Q&A session, I'll leave up the screen with contact information for Ross if you'd like to contact him following today's webinar. Let's get started. Ross, the first question I got here is, how do I figure out what the level of detail of my data is?
Okay, yeah. So the best way to really figure out your level of detail of data is to do a view underlying data in Tableau, or just generally, try to look at the row level of detail. So look at rows from the table that you're connecting to or that you're looking at, whether you're using SQL or anything else, and really look at, in particular, the measures, the numbers that you are interested in, and look at what are all of the columns that are associated with that, and what uniquely determines that, right? So an example again is with that product information, we had product, quantity, item amount. Sometimes the column names can help as well. But you do have to be careful because sometimes these things are repeated, right? So if I have that employee salary information and I have that employee name in my data, even though it appears at that, what appears to be the product LOD, if you look at it, you'll see that it's repeated. And so if you see numbers that are repeated over and over again, or that's something to be a little wary of in terms of figuring out if something is actually at that LOD, or if it's been brought in from a different level of detail and simply repeated. So I would look at the underlying data and then just look to see what values are changing and what values are repeating.
Super. Next question, Ross, is how do I know if the data I have is giving me the right answers?
Yeah, so that takes a little bit of practice. The best thing to do when you first encounter a new set of data is to really just kind of ask some, do some initial analysis to sort of, verify that it is giving you what you expect. So, you know, build some visualizations or run some queries to where you sort of know what the answer should be, right? Like you have a ballpark estimate for what things should look like. And then you can sort of verify, you can get some trust in the data that it's giving you the answers you expect. An example is, again, with that salary information, right? It's sort of like, oh, well, if I look at the salary per person, it should be, in some sort of range that I expect it to be in. So those are the best ways, is sort of, in a way, ask questions where you know the answer, you have an estimate for what the answer should be, and verify that it looks correct.
Super. If I'm not using Tableau, how should I think about LOD?
Yeah, so I've talked a lot about it in terms of Tableau, but really it's sort of just about the fields in your data, and a lot of times if you're not using Tableau, you're using SQL or you're using some sort of engine to aggregate data, right? Whether it's R or SQL or whatever else. And really the best way to think about it in those sort of very technical environments is going to be, in terms of the grouping columns that you're using for your aggregates. Because fundamentally that's really what it's about is what are the grouping columns you're using when you're computing your aggregates. And again, you have to be careful a little bit of this data that's been replicated. Yeah, generally the grouping columns of your aggregates is the best way to think about it.
Okay, can you explain the extract LOD and how and when to use it?
Sure, yeah. So the extract LOD is basically when we copy data out of wherever it is, in your SQL database, in your Excel spreadsheet, wherever you have it, and we extract it into our fast data processing engine, Hyper. We have the ability to sort of pre-aggregate it, right? So if you think about it, normally what we would do, if you're familiar with SQL, is we would do like a select star from table, and we would dump that into a new table in Hyper. Now, when you do an extract LOD, essentially what we're doing is instead of doing select star from table, we're basically, and we only let you do this for dates because that's sort of where it makes the most sense. It's a little tough to do it for non-date things, but if you're not using Tableau, you could certainly do this in any way you want. But basically, we're pre-aggregating it, right? So we would basically be doing select product, product type, state, and then instead of order date, we would do month of order date, and then we would do sum of sales, sum of profit, sum of min employee salary, whatever default aggregate applied to all of those different measures, and so we're essentially doing a pre-aggregation as we build that extract, and then that lets you treat that as the row level, so that you can kind of do these two-level aggregates, right? So normally when you do aggregation, you're aggregating from the row level to your viz level of detail or to your result level of detail. But by doing that pre-aggregation, you're sort of doing two layers of aggregation. Now you have to be a little bit careful, right? If you were to do an average of the at that first level of detail, and then you later do a sum or reverse that, you're changing some of your answers in some sense. But essentially, it's really just pre-aggregation.
Super. You mentioned fixed LOD calculations, and how are include/exclude LOD calculations different? When would I use them?
Sure. So fixed LOD calculations are, basically where you say here is the level of detail that I want this aggregation to occur at, and Tableau can just do that. Include/exclude are calculations that let you augment the viz level of detail. So, and they're really useful for doing things like totals and these two-layer aggregates that I talked about. So, I originally, in my example of extract LOD, I talked about how I wanted the monthly, the average monthly sales, but my data was at the day level. So I suggested you create an extract at the month level, and then when I do my average, it does the right thing. Well, another way I could do that now that we have LOD calculations is that I could say, include month, sum of sales, and then wrap that with average. And what that would do is it would take my viz LOD, add month to the grouping columns, and compute the sum of sales. Then from there, it would do the average. And so the cool thing about that is that you can do these multi-level aggregations. Similarly, if I wanted to compute a percent of total, I could say, if I want the percent of total sales for each product, I could say something like exclude product sum of sales. And so if I take sum of sales at the viz level of detail and divide it by the exclude product sum of sales, then what I'm doing is I'm removing product from the aggregation. I'm getting something that is at a more aggregated, less granular result, namely the sum of sales across all products, and I can compute a percentage at that point.
What is the best way to control LOD in a single visualization so that the denominator of an equation remains variable, using the user's selection to determine it? Can a set of parameters be used to accomplish this?
Let's see. Yes, possibly. When we talk about, I'm not sure what we mean by the user selection to determine the denominator. So there's a number of features in Tableau that let you do this around applying user selection. We have the new feature, the set parameter action, which lets you use the user selection to set a value of a parameter. And so, for example, if you want to compare, I'm not sure if this is the example the questioner was asking about, but if you wanted to compare different product sales to a particular product, and you want the user to choose a product and then have the equation adapt to that selection so that the denominator of a ratio was based on whatever the user selected, then yeah, you would use a parameter to sort of name the product that should appear in the denominator. And there's a sort of trick in Tableau you use where you basically say, I want to compute an aggregate, but I only want to include a subset of my data in that aggregate. So it's not a filter because I'm not excluding the data from the entire visualization. I'm only excluding it from the computation of this aggregate. And we're working on more intuitive ways to do this using some calculations. But the way you do this in Tableau is you do something like if product equals parameter name, then sales, else null, right? And so what that does is it basically gives you a new column whose value is the sales for the product that is the parameter and null otherwise. And if you sum that over all the data, then you get the sum of just that product, right? So what you can do in Tableau is you can have the user make a selection, pull the product name out of that selection and set your parameter value to that. And then that calculation that you built will adapt to that, and you can use that, like you said, in a denominator to basically compare some other sum of sales to just that product sum of sales. So
Ross,
I guess,
you
bet.
Okay. Oh, sorry, go ahead.
Oh, well, I was just going to say,
Please.
so getting back to the original question, what is the best way to control LOD in a single viz? I think that what's happening there is we're controlling the LOD of that calculation. So by using that if product equals parameter name, then sales, else null, what we're sort of doing is constraining that particular calculation to a specific product LOD. Hope that helps.
Russ, thank you. Great answers to some very good questions. And for those of you that asked questions that weren't answered today, we will be sending all unanswered questions to Ross and the Tableau team so that they can follow up with you after today's webinar. Just a few quick announcements. Please mark your calendars for June the 5th, 2019, and our next Data Science Central webinar, Scale AI ML with Data Wrangling featuring Forrester. Also, today's taping will be available for on-demand viewing later today and can be found on the home page of Data Science Central in the Webinar tab located at the top of the page. And past webinars are available on demand at datasciencecentral.com. If you haven't had the opportunity to view them, I encourage you to take a look. They provide very useful insight into a wide variety of topics of interest to our Data Science Central community. This brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Tableau for their sponsorship, as well as to our speaker today, Ross Bunker, for his insight into today's topic. My name is Raphael Knut, and I'm very pleased to have been your host for today's event. I look forward to seeing you all again on June the 5th, 2019. Have a great day.